It's a moment that will change the way you think about reality forever. The moment you first grasped the concept of quantum superposition. Imagine being in two places at once, simultaneously being on the beach and in the boardroom. Sounds like science fiction? Well, it's not, at least not in the quantum realm. You see, according to the principles of quantum mechanics, particles like electrons, photons, and even atoms can exist in multiple states simultaneously. This doesn't mean they're just possibilities, but actual probabilities that coexist in a superposition of states. Think of it like a coin that's both heads and tails at the same time. Sounds absurd, right? But it's a fundamental aspect of the quantum world. To understand how this works, let's take a trip back in time to the early 20th century. It was an era of great upheaval in the physics community as the long-held certainties of classical mechanics began to crumble. Albert Einstein and Niels Bohr were among the leading figures in the debate, with Einstein famously stating that God does not play dice with the universe. But the dice were already loaded, and the quantum revolution was just beginning. One of the pioneers of this revolution was Werner Heisenberg, a German physicist who made a groundbreaking discovery in 1927. While working on the Bohr model of the atom, Heisenberg realized that it was impossible to determine both the position and momentum of an electron at the same time. This fundamental limit became known as the Heisenberg uncertainty principle. In essence, the uncertainty principle states that the act of observing a particle inevitably disturbs its state, forcing us to choose between position and momentum. It's a trade-off that has far-reaching implications for our understanding of the quantum world. But here's the kicker. This principle also enables quantum superposition, the phenomenon of particles existing in multiple states simultaneously. Think of it like this. Imagine you're trying to take a snapshot of a butterfly in flight. The moment you focus your camera, you change the butterfly's flight path, and it's no longer where you thought it was. Similarly, in the quantum realm, the act of observing a particle collapses its superposition, forcing it to choose a single state. But what if we could somehow observe the particle without disturbing it? That's the promise of quantum superposition. So, what does this mean for our understanding of reality? Well, it's a far cry from the classical notion of a fixed, determinate world. In the quantum realm, particles can exist in multiple locations, travel faster than the speed of light, and even appear before they're created. It's a universe that defies our intuitive understanding, where the impossible becomes possible. One of the most fascinating implications of quantum physics is its potential for quantum computing. Imagine a machine that could perform calculations at speeds and scales that would be unimaginable with classical computers. It's a prospect that has captured the imagination of scientists and entrepreneurs alike, with major players like Google and IBM investing heavily in quantum research. But quantum physics is not just about technology. It also has profound implications for our understanding of the universe itself. The phenomenon of quantum entanglement, for example, has led to some extraordinary discoveries. In 2017, researchers at the University of Innsbruck observed two entangled photons separated by an astonishing 1 kilometer, confirming the strange connection between particles across vast distances. As we continue to explore the quantum realm, we're being forced to redefine our notion of space and time. The concept of locality, once a cornerstone of classical physics, is no longer tenable in the quantum world. In its place, we have quantum non-locality, a phenomenon that allows particles to instantaneously communicate with each other, regardless of distance. It's a concept that's hard to wrap your head around, but it's at the heart of some of the most intriguing phenomena in the quantum universe. So, what can we say to those who are skeptical of the quantum world? Well, the data doesn't lie. Experiments have consistently shown that quantum physics is real, and it's here to stay. In fact, the implications of quantum physics are far-reaching, going beyond the realm of fundamental science. The principles of superposition and entanglement are already being explored in fields like medicine, materials science, and even cryptography. So, while the quantum world may be strange and unpredictable, it's an area that promises to revolutionize our understanding of reality. As we close this journey into the quantum realm, we're left with more questions than answers. Can we truly grasp the nature of reality, or will it forever remain shrouded in mystery? The quantum world is a reminder that, no matter how far we've come, there's still so much to discover. And it's in the pursuit of that discovery that we'll find the answers to the biggest questions of all. So, what's the biggest implication of the quantum world? Is it the potential for quantum computing, the discovery of new medical treatments, or the profound insights into the nature of reality? Whatever it is, one thing's for sure. The quantum world is a realm where the impossible becomes possible, and it's an area that promises to change our lives forever. But for now, the question remains, what lies beyond the edges of our understanding?